Uh, 0.1 mole of potassium hydroxide is reacting with zero point 0.1 mole of nitric acid. Obviously, this is the reaction in which there is some enthalpy change. So the enthalpy change they have given you transferred to the surrounding. Obviously, the reaction is exothermic. That's the reason the energy is transferred to the surrounding. What is the enthalpy change in kilojoules per mole? I would say I would say this much energy, this much energy is released through zero point 0.1 mole. Through zero point 0.1 mole. How much the energy would be? How much the energy would be if I have 1 mole? If I have 1 mole, because they are asking per mole. Per mole bole to 1 mole. So first of all, you have to cross multiply this. Okay. So that would be 5200 divided by zero point 0.1. What's the answer? Yes,
52,000.
52,000.
52,000 joules per mole. But they are asking in kilojoules per mole. So of course we have to convert the joules into kilojoules. That's the reason I'm going to divide it by 1000 and I would be getting minus 52. Why minus
Sir,
52? Why not plus 52? Because in
totally
your
exothermic.
calculator, yeah, exactly. So you must know the type of reaction. They are not mentioning in this question ke, whether the reaction is
Sir,
exo or endo in simple words. You have to identify by yourself by looking at ke bhai energy were transferred to the surrounding. So is tarah se I identified the reaction. That's the reason A is correct rather than doctor. D for doctor. Yes, Abdullah, kya keh rahe the?
sir, you're comparing to 1 mole because they said what is the
Yeah.
enthalpy change in kilojoules
हाँ
per
अगर
mole,
आपको
right?
याद हो हमने जितने भी प्रोसेस डिस्कस किए थे दैट वर ऑल पर मोल कंबशन पर मोल न्यूट्रलाइजेशन पर मोल फॉर्मेशन पर मोल एटमाइजेशन पर मोल हाइड्रेशन पर मोल सॉल्यूशन पर मोल ऑलवेज यू विल सी किलो जूल्स पर मोल ऑलवेज ओके
Okay.
यस
Kilojoules.
kilojoules per mole that's the standard unit for this yeah do this
Sir, can
make
you
it jaldi
scroll up to the end to take a screenshot of the question? 1 minute.
So
uh,
you
Okay.
cross multiplied the
exactly
500. Okay.
yes
Okay, sir, done.
ओके जल्दी जल्दी फटाफट क्वेश्चन नंबर 2 जल्दी फटाफट आई एम सेइंग दैट द आंसर इज चलो पहले अब तुम बताओ फिर बताऊंगा मैं of course you have to convert this equation into the displayed formula otherwise you will how you will get to know कि कौन सी value where I am supposed to put okay साथ साथ मैं भी कर रहा हूँ okay this is H2 that is for 436 plus 0.5 into 498 and then H2O means 464 into 2. 464 into 2. Yes, what's the answer? Mhm.
Minus 243.
Exactly. A is your correct option. A is your correct option. Okay. Easy है चलो जी बिल्कुल बेबी क्वेश्चन है दिस इज द बेबी क्वेश्चन नाउ यू कैन सी दिस no it's the hydration I would be telling you this afterwards yeah see this the standard enthalpy change for the combustion of graphite is minus 393.5 and that of a diamond is minus 395.4 kilojoules per mole What is the standard enthalpy change for the reaction below in kilojoules per mole?
So
In
what was the
kilojoules,
answer for the previous question?
minus 243. A option was correct. A option was correct.
So we're gonna do product minus reactant, right? No, reactant minus product.
Yeah, because that's the bond energy. Okay.
Okay, but I'm getting the wrong answer. I'm getting
Bear with me.
530. So minus 243.
Exactly. आसान तो है. Okay.
सर
So,
मैंने कोई कैलकुलेटर में गलती की है.
mhm. Yes. What's the answer?
B.
B for ball, D for doctor.
B for ball.
B for ball. How you did this, Roma?
Since it's combustion, the arrows will be pointing downward. So
Exactly. So
the
means that you
sign
are
for
making Hess
graphite,
cycle. You're making Hess
the
cycle, I
sign,
think so, right?
yes,
This is
the sign
minus
for graphite would
393.5.
stay the same.
And obviously this is also the combustion, right? This is minus 395.4, and then you would be doing just like that. And of course I'm not going to change the sign of this minus 393.5, but I would be changing the sign of this. So of course the answer would be positive 1.9. The answer would be positive 1.9. Okay. So since you can do this like the reactant minus products, you would be getting your same answer. Reactant minus product, reactant minus product. You would be getting the same answer. Rather than to draw the Hess cycle, you can apply the direct formula, that is reactant minus product. Okay, because this is the combustion question. The data given is for the combustion. That's why you can apply this formula. Okay. Now see this question number 5. Question number 5. The standard enthalpy, the standard enthalpy change for the neutralization when an acid reacts with an alkali is the number of kilojoules released by when I was telling you enthalpy change of neutralization, so I told you it's the energy released when 1 mole of water is formed. It is the energy released in kilojoules per mole when 1 mole of water is formed. When 1 mole of water is formed. So of course, if you know the definition, so you would be writing down the answer. But if you don't know the definition of a standard enthalpy change of neutralization, so you won't be able to do this question. Right now, I'm telling you the definition of neutralization. So according to that definition, the answer is B for ball. Okay, the answer is B, because in this process, 1 mole of water is going to be formed when acid is going to react with an alkali, and this is neutralization. Okay, again the same question. Hopefully you will do this question. I'm skipping this question. Okay, we have to do this question. Question number 7. First of all, you are supposed to try this, then I would be telling you. Yeah, start. Uh-huh, 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 uh-huh. Okay.
B for ball.
Okay, B for ball. Okay, बाकियों का देखते हैं. Yes, 7. This is the formation question. I'm going to do this directly because this is your MCQ. Examiner would not be like looking at like how you did this question by the Hess's cycle, by drawing the cycle, or you did directly. I'm going to do this directly. That is real the product minus reactant. So
I got
390, okay, into 2 into sulfur dioxide is minus ka 290. This is product minus reactant, that is CS2 110. Of course, oxygen is the diatomic element. I'm taking it as 0. So, yeah, what's the answer? Yes?
D.
Yeah, D for doctor is correct. रोमा तुम्हारा
ओके।
बी आ रहा था ना, बी फॉर
तो
बॉल.
फिर आप प्रोडक्ट प्रोडक्ट माइनस रिएक्टेंट क्यों
Sir,
कर रहे हैं? वैसे मैंने इजी आंसर मिला है पर
may
प्रोडक्ट.
times think other by 2.
Oh, okay, 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 okay. Uh,
सर
this is
आप
the good one
प्रोडक्ट माइनस
question.
रिएक्टेंट क्यों कर रहे थे इसके अंदर?
बेटा formation है, formation. I told you formation. This is formation. If this would be combustion, then you would be doing reactant minus product. Okay. If
ओके।
this would be combustion, that would be reactant minus product. Yeah. See this question number 8. The reaction for which the enthalpy change is the standard enthalpy change for the formation of water. You know, they have written 298 Kelvin. That's the standard condition. That's the standard condition. Okay. So, of course, you can see the same equations. That's going to make you
A.
confused. So,
Yeah,
A
A.
is correct option. A is your correct option. Can you tell me why not B is your answer?
The standard state of water is liquid, not
क्या
gas.
बात है यार, एग्जैक्टली क्या बात है. यस 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 यस, दैट्स द रीजन. इन every process we write under standard condition. At least you must know the standard, like you can say state samples for the elements or a compounds. Of course the water is liquid at room temperature, it's not gas, it's not steam at room temperature. You have to provide some sort of heat.
सर व्हाई नॉट
uh,
सी?
why not C? Because if you remember, we used to tell you that 1 mole of water is formed. 1 mole of water is formed. In this equation, you can see the 2 mole of water. Technical error in this equation. Of course, same goes with D. Okay.
ओके।
Question number 9. Yes. Question number 9.
C.
C. Okay. हाँ भाई रोमा. Question number 9. Question number 9. Carbon fluorine bond. You know, they are
सर व्हाट डू
saying
दे मीन बाय द मीन बॉन्ड एनर्जी ऑफ द हाउ
basically
शुड वी
bond
नो?
energy की बात कर रहा है. You know, if you remember, when we were putting the values for the bond energies in the equation, so we were writing down the displayed formula. So they are asking the value for the CF bond. For the CF bond, like if you have the carbon tetrafluoride, that is this carbon tetrafluoride, that is this, he's asking to find out this value. He's asking to find out this value. Okay, that is the carbon and fluorine value. So of course, uh, you know, you must have an atom. You must have an atom. Okay, you must have an atom, remember. And so of course the answer is B. The answer is B, remember. Which equation represents the reaction for which the enthalpy change is the mean bond energy of the carbon and fluorine bond? So you can see this equation is balanced. This equation is balanced, and 1 mole of a fluorine is formed. 1 mole of a fluorine is formed. So, you know, 1 by 4, 1 by 4. Carbon is balanced. 1 by 4, and this is 4. They would be cancelling each other. They would be cancelling each other. There would be one fluorine and there would be one fluorine. Remember,
ओके
whenever
सर
you
आई
are
हैव
going to
ऑब्जर्व्ड दैट
write
द वन
down
अबव इज
the,
आल्सो बैलेंस्ड।
sorry,
द वन अबव इज आल्सो बैलेंस्ड।
no,
Yeah.
it's 4 mole of fluorine. It's 4 mole of fluorine. Remember,
Oh yeah, for
you need
both.
you need an atom. You need an atom. You need an atom for fluorine. An atom for fluorine. Okay.
So I have a question, sir. Where did you
Yes.
get the hint that you need one atom of fluorine? How did you know when you saw this question that you
Let's
need
suppose
one?
if you have a compound and you are going to break down your compound to find out the bond energy, okay, to find out the bond energy, in the data booklet or any of the data that you have provided in that paper. So when we are taking the bond energy from the data booklet, let's suppose the bond energy for chlorine is 242. Chlorine means it's Cl2. Chlorine means it's Cl2. That is what? 242. But if I need one chlorine, so I would be dividing it by 2. And in most of the cases, when we are solving the bond energy questions, so we do the same thing. So whenever you can see any of the question related to the bond energy, so this is the standard method to form an atom. It's more better to find out the bond energy of an atom. If you remember, I was telling you atomization, ionization. I told you energy required to remove an electron from the outermost shell of a gaseous atom, and we are more interested in atom, so it's a standard form. So that's the reason we will try our best to find that equation in which I can see atom in the product side. So that's the reason B is your correct option. Okay.
Okay.
Yeah,
And sir,
in the
what about the
product
one
side.
that you just get cancelled?
So you are not supposed to put any number between before you know 1 mole of a product is formed. So that's the reason when I was balancing this equation, so I put 1 by 4, and the whole equation is balanced. Basically, I have to make one atom of fluorine. So there is only one way to balance this equation. That is this, that you have to write down 1 by 4.
So this is enthalpy of atomization.
Yeah, enthalpy of atomization. Yes. Okay. See this?
Okay, sir.
This is a good question. Given the following information, the mean bond enthalpy for the carbon hydrogen bond in methane is nice question.
B.
Yes, B. Because I have to find out one carbon hydrogen. They have given CH4. CH4. This is 4x. This is 4x. I have to find out x. So 4 is multiplying over there, and that it would be dividing by the q. That would be q by 4. This is positive q, so that's why the answer is B, not D. मैं तो बिल्कुल ही again the same question. I'm skipping this question. This is very easy. Okay. Yeah. See this formation question again. This is the formation question. Hmm? What's the answer? ना आसान है, जल्दी बताओ ना. Ibrahim, what's your answer? You can do it directly. You
I
can.
get A.
I get
Sir, how
A.
can you do that?
A.
Yeah.
A. Oh, okay. Yeah, A is your correct option. Ibrahim, are you
Sir,
getting
how?
A?
No, how did you do it directly?
Formation is product minus reactant. Formation is product minus reactant. Product is water is minus 286. The coefficient for water is 4, and and okay, and this is I'm going to apply the formula, that is delta HF is equal to product minus ka reactant, since the delta HF is also given to you, that is minus 2440 is equal to this is 0, this is 0, okay, and this is we have to find out. I am calling this as I am calling this as X, that we have to find out react, okay, that we have to find out, okay. This is my reactant, so this is X, and then carbon dioxide is minus 394 into 4, and then water is also 4, and the value for water is minus 286. You can find out X. You can separate X. You can separate X.
Okay, okay, got it. I got A.
Good,
And
good,
because
good,
it's
good.
combustion, which is an exothermic reaction,
It's
it's going
not
to be A.
combustion.
Can't
It's combustion. It's combustion.
yeah, yeah.
Overall
Sir,
equation.
it's not formation then, sir.
Overall equation is combustion, but they have given you the formation data. That's why I'm following product minus reactant, not reactant minus product. Okay. It depends
Okay.
on what the data is given to you. Remember, this is very important concept. It depends on the data,
Okay.
that what the data is given to you. Is the data related to formation? Then apply the formula product minus reactant. And if the data that is given to you is related to combustion, then you can apply the formula that is reactant minus product. Okay.
Sir, can you please send this worksheet on the group?
Okay, I'm sending you this. Uh, yeah. See this? 14. See this? Uh,
B.
B for ball
Oh
or D
no,
for
D.
doctor?
No, D. D for doctor.
D for doctor. Okay.
Yeah, I also get D.
The standard enthalpy changes for the formation for the carbon dioxide and methanoic acid are. This is 394 and this is 409. This is 409. Since the coefficient is 1 and 1, since the coefficients are 1 and 1, okay, so they are asking the formation. They're asking the formation. So I would be applying the formula, that is product minus reactant. So product is 409, reactant is 394.
I got
So the
C.
answer would be, so the answer would be, yeah, yes,
B. B.
15.
Yeah.
15, yeah, okay. Okay.
So why is
I
it
think
D?
so. This is
D
D.
is the
This is
same.
D because this would be minus 15. I think so. It's an error.
Okay.
It's a typing error. Okay, because this is plus 15, right? So I'm getting plus 15. So that's why I can say the reaction is endothermic. Okay. Yeah. This is a acha question. See this question number 15. Good one.
Sir, but would you the CO2
Yeah.
when you draw the diagram of formation, the arrows are up, right?
Yeah.
And 394 is positive, so it should be
Yes.
negative because it will be going down.
Yes.
Okay. So when you bring 394 to the
But
other
I
side,
would
it should be
recommend you to write, I would recommend you to solve directly if you are going to solve in MCQ. But if you have a paper two question, like sorry, theory question, so you can draw the bond Haber cycle. Sorry, Hess cycle.
okay.
Okay. See this question 15. Value is negative.
Is it B?
No, D is molecule to atom.
No,
Molecule
no,
bond is
B.
going to break down.
No,
Yeah.
B, second one.
A.
Second one, C is correct. It's going to gain electron. B mein bond is going to break down. This should be endothermic. It's bond breaking. Bond breaking is always endothermic. Okay. Okay.
Wait, I don't understand. How is C the answer?
C is going to gain electron. Gain of electron is electron affinity. When something
Sir,
attracts to
because
each other, it should
bond
be
making is
exothermic.
exothermic, right?
Yeah, it's bond making. Electron is going to gain by this chlorine. It's bond making. Okay.
Yeah.
Okay. Yeah.
And bond breaking is endothermic.
Yeah. Okay.
So exo. Bendo mexo.